everyone, welcome back to my YouTube channel. So, today we have a new video, quite an interesting one, on the little model lathe. So, let me see if I get the lighting right here because it's quite windy outside and I have the door up full. The door down a little bit here. Okay, so I think that's not bad. So, just ignore the rattling noise in the background, it's just a shutter door shaking about. So this is part 3 of the little model lathe, the little modification for the digital motor attachment on the sliding mechanical mechanism. Now I have complete the electro tensioner, so basically by the flick of a switch I can tighten the belt in 3 different stages. So, what I'm going to do is I'm going to do finish off the part 3 now in the electro tensioner for the belt. Then in 4 weeks time will come part 4 of the control panel, making the enclosure and stuff like that. Part 5 then will probably be finishing the lathe off completely, painting it, making the stand for the bottom of it, and yeah. So what I'm going to do now is going to bring the camera up and I'm going to do a demonstration of the tensioner working. Then I'm going to attach all the video clips that I have made over the last, I think it was actually maybe 2 weeks since I worked at this lathe now. So video clips that were done back then, just all attached together, the manufacturing process. Then I will do a final video just closing off part 3. Then we will move on to bigger and better things in the future. So yeah, we'll bring the camera up now and do a full walk around. I hope you enjoy. It's really interesting, a really interesting and quite cool way of tightening and slackening the belt. So I don't have to slacken nuts or bolts or anything like that between the 3 different stages, or the 3-stage pulley. So here we go. Okay, so hopefully you can see that nice and clear there. I'm going to do a wee demonstration before I start moving on to the manufacturing process of this pre-tensioner. So where should I start? So you probably see here that this motor plate is all changed. I will explain that in the video clips that will follow, why I changed it. Yeah, so we're going to move on here now and give a little quick demonstration, moving between the highest gear and the lowest gear. So the lathe currently sits in the highest gear. The belt is tight. If I want to slacken the belt, I basically apply 12 volts to this little pre-tensioner. So there we go. We have the belt slackening. So that's enough. So if I want to move on now to a lower gear, or to say the middle gear, I basically slide the motor and the actuator, the pre-tensioner, over to the middle, sort of line the 2 pulleys up. So that's them aligned. To tighten the belt again, I basically apply power, 12 volts, to the motor until you hear the motor sort of gurning. At the minute, that's just the way I'm sort of doing it, but in the future I will have some sort of a current sensor circuit there that, it will stop the motor in over tightening the belt and breaking the parts in the gearbox here or something like that. So that's the motor in the middle gear. So what I'm going to do now is I'm going to put the lathe into the lowest gear, slackening the belt again using the 2 wires. So no bolts, no nuts to slackening, so it's basically a quick change. Slide the actuator over, place the belt on the right pulley, the V, on the 3-stage pulley, which it's on now at the minute. Then we tighten the belt again by using the 2 wires. So just to hear the motor gurn. So that's it. I think I might just go down the gears too, just to demo it. I may as well. So to slacken it, reverse the polarity, move the motor across. I've actually went too far. So what do we see? So move the motor across, like so, and just drop the belt down. Oh, came off there. So that we're on the, we'll go for the middle gear. It's a wee bit sticky. It needs a wee bit of grease in the sliding shaft, but it works. So to tighten the belt again, we just like so, till you hear the motor gearing. Then to slacken it, reverse the polarity. We're going to go for the lowest, or sorry, the highest gear, which is the smallest pulley. And we're going to just slide this across. That's it. So we tighten the belt again. There we go. So yeah, that's it. I can actually have the belt much tighter if I want. There. But a quick wee nudge, applying the power. So look how tight the belt is if I push on it here. It's extremely tight. So that's it set, ready to turn the spindle motor on. I'm not going to do that, but I might do it at the end of this entire video. So we're going to move on now to the manufacturing process, and yeah, take it from there. I hope you enjoy. Okay, so the first step would be to make a flange stainless steel plate for this. I'm going to be using 3mm plate. So first things first, so this plate is used to contain the bearing on this gearbox. I'm going to remove this plate and basically make a nice neat stainless steel plate that basically just a clone of this plate. However, it won't have the bevel here at this point. So what this plate is doing at the minute is containing the bearing. I will also be using the plate at this point as a bracket point, a mount point. So I will be welding sort of like a cylinder to it. So it sort of sits over the linear screw. This is to ensure when I place a linkage point that it is center to the shaft at this point. So that's important. There's not much point me having this basically a bracket, say having this at a offset to either side of the gearbox, because when the linear screw is protruding in and out, it will cause binding issues within the shaft, and basically the motor won't move. It'll basically just stick there because of the angle with respect to this point and respect to the linear screw. So hopefully I'm making sense. So on a digger, for example, you would see the pivoting points being center in line with the shaft. You're not going to see them sitting offset like so. So what I have to do, as I say here, is I have to place the cylinder over the screw for about approximately 50mm of the stroke that sort of will enter the cylinder. Then I will have this bushing on the end of it, the pivoting point, the main pivoting point, and hopefully it all goes well. So we're going to start cutting this little plate now, and then we will place the plate on the motor and weld on, well, first things I have to cut this first, weld this to the plate, and then another nice heavy plate on here, maybe 5mm, and then this welded to it, this little bushing. So hopefully it all goes well. Okay, so before I start modifying this little actuator, that was removed from a car seat. So it's adjustment of a car seat. Not sure what part it was. I think it was maybe crimping your sides in the car seat. Not sure now, but okay, so it's a short stroke of about approximately 100mm from this point to this point. Maybe a wee bit less actually, 90mm. I have more linear screws that I could place in here if this one's too short. However, I think it's okay. So I'm just going to give a wee demonstration on where this actuator will be positioned to create this little adjusting mechanism. So I'm thinking about placing it at this point. So it's quite tricky. So we'll see if I can start. So when the motor is down on the lowest gear, when the motor is extended out away from the lathe, we need this actuator screw to be in at this point. So it's actually sitting in here. We need a wee bit of tension left to tighten the belt. So we'll leave probably about 10 mil when it's down. So I'm thinking about something like this position here. So what I need to do now is make a bracket here for the back. All stainless steel again. And right, we'll get onto this in a minute. I'm just going to show a demonstration where it is at the minute, and then we'll get into detail of this actuator. So I should point out, right, when the motor is up at this point in the highest gear. So just to clarify, part 2 was the making of this sliding reel. So I'm not going to start talking about it. So just going to touch on it. So when the belt is slid over on the sliding reel, to the highest gear, which is on now at the minute, the motor is sitting closer to the spindle or the centre of the lathe. So we need this actuator to move on this axis too, to follow the motor itself. We also need the motor to pivot on this axis, just much like a ram on a digger. So we can't use this sliding reel here because of the stroke. We have to now create a new sliding reel at the bottom, or a sliding runner or sliding shaft. So what I'm going to do now is I'm going to start modifying this wee actuator, and I have it in my head what I need to do. So we'll go to the bench here now, and so in the highest gear we need this motor sort of sitting in this angle to tighten the belt, but the stroke this time will be out because it basically pushed the motor up. And then to tighten the belt again at the highest gear, we just simply reverse the polarity to this motor and tightens the belt down the hill. So hopefully we get the linkage points right, because I need to point out here, so I can't have the pivoting point here and here. It has to be sort of in line with the screw, the bar, again, just like a ram on a digger. So I need to have a bracket here. I need to have a little special housing, cylinder housing, that allows this screw to pass down through it, and then we'll have another linkage at the rear end of it. So that's what I'm thinking. So we're going to take it to the bench here now, and hopefully it all goes well. Okay, so that's it, more or less finished. A wee tidy up now with a file, and we will place it on the gearbox. Okay, so the little plate is now finished. Next step now is mounting it to the gearbox. So you can see the little bearing I was talking about in the gearbox there at one side of it. So that's basically, if I can probably pull this out. Well, it's not going to come out now because of the screw and this little washer on the linear bar. So this little plate will contain the bearing, like so. So we might put the brushed finish up the way. Okay, so there we go. Next step now is cutting a little cylinder that will be placed over the linear screw. So approximately with the screw fully in, we will measure the shaft. So a cylinder of approximately 45mm will get us away. And we will cut this little threaded part off here now. Okay, so next step now is cutting this little stainless steel pipe. So I need to leave enough length so I can actually place this little plate, which is 6mm thick, inside it. Then we will weld this little bushing to the 6mm plate, like so. For the meantime, I might leave this little tube at approximately 60mm, just in case I want to change the length of the stroke using this longer linear screw bar. Just in case we don't have enough movement. So what I'm going to do here now, this is the only bit of 25mm pipe I have, so I have to be careful. What do we see? So I need 45. So if I cut it at say 60mm, just for now, and then I can downsize in the future, if need be. Just in case I need to, as I say, gain more stroke here. So I will do this by making up a new linear screw bar. So this linkage will need to be welded onto this bar and ground it down. So a wee bit more work in that. So hopefully we don't need to do that, but here we go now. So we'll start cutting this cylinder. Okay, next step is making this little 6mm plate to fit inside it. So I will basically just draw around this here now and cut a nice little plate that will fit inside it. So this is for strength. We want this point strong. There's no sense me welding this bushing onto the pipe like this because, well, it's never going to be a good job. And if it's a bit of 3mm plate, there's a good chance this could break off. If it was a bit of 5mm or 6mm plate placed inside and welded around this cylinder, or the outer edge here, then this bushing welded to the 6mm plate, there's adding much more strength. So you might flatten this a wee bit too at the edge, just so it's sitting flat on the plate. We will do that using the grinder. So the next step now is drawing a little circle around this and cutting it out. Okay, so at the minute it looks a bit like an octagon, but I will grind it into shape, into a nice circle. So this tube is 1.5mm wall thickness. So that gives it 3mm. So 3mm over 25 is 22, so I need a 22mm diameter circle. And so a wee bit of grinding just to make this fit nice and neat. So I'll do that off camera, take loads of pictures, and I hope you enjoy. Okay, so we have this little 6mm cylinder-like plate. Well, it's finished and ready to be pressed into this 25mm pipe. So, as I press, I'm going to hit a little hammer here now. Once this is complete, I can then start, creating a point on this bushing that is flat. So basically, I'll just be taking off a shaving with the grinder. So it sits nice and neat with this plate, and yeah, so basically it's just easier to weld it, and well, it'll be much stronger flat rather than sitting up on its edge too. So I should point out again, as I already mentioned anyway, that this length of the cylinder is not final. So we might trim this in later stages off this end, maybe 10mm, depending if we have to lengthen the stroke of this little actuator. So we'll tap this little bushing in here now. Let's see if I can lower the camera down a wee bit to the bench. So hopefully this fits. We'll go for the good edge because, as I say, this edge might be trimmed again. So you can see there now it's fitting nice and neat. Basically just squeezing in. This will then be welded around the outside once everything's working. So it's a little tight yet. See if I get her in here somehow. Okay, so it doesn't want to go on when I give it a wee grind here. Okay, so finally it went on. So what I'm going to do here now is I'm going to bring this up flush. So next thing is we're going to start with this bushing here now and create a flat edge on it. So basically it can be welded on like this. So there we have it, nice and flush, just the way we want it. So now we're going to start this bushing. So basically here I'll just grab it with a vice grips, so I keep the grinder as far away from my fingers as possible. Okay, there we go. So this now can sit flat. So it's starting to look like a wee ram here now. And little cylinder part of the ram. So once this bushing's welded, it might get a wee bit tight. So I might need to give it a wee remount to 16mm again to fit the shaft. Or sorry, the bar. So looking good. Okay, so we're ready to weld this little cylinder piece together that will be used on the back of the actuator. So I have to make sure first, now that I've battered this 6mm, or pressed it in with a hammer, or battered it in with a hammer. So I have to make sure that this little plate is sort of perpendicular to this edge at this point, and also 90 degrees, just to make sure it's nice and flat. So I'm going to tack this together here now with the tag. So I'm just going to fuse it in a couple of spots in the meantime. Then we'll weld this little bushing, this 16mm bushing onto here, centralized. So here we go. Okay, so that's it, tacked in 4 places. Next thing now is the little bushing itself. So I have to make sure this is centralized. So basically, if you think about it, looking down on it, probably the best way to get that centralized. Then looking at it sort of straight through this way, and also straight through this way, 90 degrees out again. So what I'm going to do here is I'm going to look down on it. I'm going to take a couple more pictures first before I start welding this up. Okay, so what I'm going to do here is I'm just going to tack it first, line it up as close as possible. Then we will start measuring it using, well, the edge of the square. So basically, this point here, we will make it equal both sides. I think it's the only way to do it, really, and use your eye. So I've got a wee fine rod here now, so it's basically MIG welding wire, stainless wire. I think it's about 0.6 thick. So I'm going to put a wee tack on this at the back. I'm going to turn the welder up a wee bit first. Okay, so we're now set at 50 amps to do this. Hopefully this turns out nice and neat. Okay, so that went well. Now we have a nice neat tack in this corner. We need to place one at this corner to ensure it pulls over onto the flat surface. I'm just going to square it up here first using this little square, make sure we're equal both sides. So what do we see? I say that's about right there now. So if I flip this over now to the side, you can see it's a wee bit too far this way. So the only thing to do here would be to tap it that way a wee bit. Sort of so what do we see now if I adjust the square again? Okay, so that looks good now. So next thing we need to make sure now that it's square, so that the bushing's parallel. So say if you drew a line up the centre of this tube, and then you sort of look at this flat edge on the bushing, you want to make sure that bushing is running through to this the center line of this tube. So it's a wee bit off at the minute, but when I put a tack at this side, it'll pull over. Okay, so it's looking as square as we're going to get it. I think the only thing to do here is to weld it up. It's not easy. It's not easy because the stainless pulls like mad. So you sort of have to go past, set it offset, and then let the heat pull it onto its sort of square. So I think we're going to try it at that now. So as I say, it's been that's actually been pulled in now with the heat. As the weld sort of, is it contracts or? So it's difficult to keep it straight. So you have to keep a wee gap at one side and tilt it past, a wee bit past 90 degrees, or so say the bushing and this cylinder here. I have to actually set it at a wee angle first, let it pull in with the heat then to it's straight. So it looks okay now, so we're going to put another tack on it. So again, that heat's having an effect on it. So there we go, looking good. Starting to look like a wee ram here. So next thing now is welding this to the little plate that I made earlier for the gearbox. As I mentioned at the start, it's probably the third time I mentioned now, this cylinder is oversized for the meantime. Just to get a wee sort of insight into how it's going to be mounted to the lathe, and if the sliding bar on the lathe needs to be adjusted. It probably will be made 10mm smaller, but not at the minute, until we determine the length of the shaft, the length of the linear screw required. So now we're going to start, tack this to the little gearbox now. Okay, so I've decided, due to the how complex this little mechanism is going to be on the lathe, I decided just to go ahead and cut off the excess material on this little cylinder. So at the minute, if I measure up the inside here, we have 55mm. I obviously want this as short as possible, but I also require this linear screw to be the correct length. So if this is too short, it's not going to tighten the belt at the different positions. But we also need room for this linear bar to pass out the back. So at the minute I have 10mm too much on the cylinder once I weld it onto this plate that I've made here, this 3mm plate. So what we're going to do is we're going to trim 10mm off it. We're going to weld it to this face, and then we're going to attach it to the lathe and start making the little sliding bars up for it. So here we go. Okay, so we're now measuring 45mm. The shaft protrudes out the back of the gearbox, the linear screw, 42mm. So we have 3mm to play with at the back, so that's enough room, more than enough. So what I'm going to do here now is I'm going to weld this on to the 3mm plate, but we have to keep in mind the angle we want the gearbox to sit, the motor to sit, and the gearbox when it's adjusting in and out. So I can obviously adjust this at the minute by, I can vary it wherever I want to weld it. So we'll take it to the lathe, get an idea of where we want to position it, and then we will tack this up. So all going good. Okay, so the next step now is trying to figure out where we want the mounting points for this little actuator. So tensioner even. So I'm thinking at the minute. So we have the motor in the lowest gear. Okay, so that means that the linear screw will be in full, if not a wee bit extra left on here. As you can see, what do we say, to tighten the belt. So I'm leaving about 5mm at the minute. Just to get things sort of tacked up here and there. Okay, so we want this motor mounted at approximately, well, in this position. So we want the motor here where my thumb is, sort of angled in below the motor that turns the lathe. So rather than keeping it like this, sticking out straight, hitting your leg and stuff. So what I'm going to do is I'm going to tilt her in there at a 45-degree angle. Next step now is making a pivoting point at the motor here on this bracket that I have made. I think it was part 1. And then we also will have another pivoting point along here. So basically I will have another sliding bar about 50mm down from this one. It'll be parallel to it. It'll be directly below it. So I'm going to start with that now, and we'll slide this little piece on. Then we can determine if we want, or where the angle, where we want the tensioner positioned, the little motor of the tensioner. So we'll start with that now. We'll start cutting the round bar and tacking things up, just to see, we'll see how it goes. Okay, so we're going to start by cutting 2 pieces of bar. The first piece is going to be 3 inch, and the second piece is going to be about 2.5 inch. Next piece now is the piece that'll be going downhill. So this piece will be sitting vertical, facing the ground. Okay, so we have these little pieces of stainless bar cut. We have the little ram, cylinder part of the ram, the electro ram on the shaft. So this is the way it will sort of positioned. So this ram will slide over the distance of the pulley, the width of the pulley, sorry. So the pulley is approximately 40mm between the V's, the 3-stage V pulley. So what I'm going to do here now is I'm going to tack this bar on first. So it's important that this bar runs sort of, well, perpendicular to this face, to this sliding bar, so this way. And also, it's also important that the bar is vertical through to the lathe itself. So what I'm going to do is I'm going to put this plate on just to square things up, and we're going to tack it on here. So we're keeping the bar flush to the top of this one. Okay, so that's it tacked on. Looks good. Now you give it a wee tack at the bottom just. So, the next one now is welding this one onto here. Let me see if I bring the camera around the better angle here. Again, using this plate to keep this bar flush with this one. I'll put it at the back this time. So that's it, nearly, well, tacked. Making sure it's all square now just. Tricky to get in here. Okay, so it's attacked. Now we're going to test it out. Okay, so we're just going to put a final couple of welds in this before we move on to the next stage. So just a couple of good tacks for the meantime. It's hard to get in here now at this. Okay, so I'm going to have to take this off. Get a wee tack in the back just so it pulls this bar in towards the lathe, because the heat tacking it this side has made it pull. So I'll take it off and give it a wee tack, then we'll put it back on and finish the rest of the tensioner itself. Okay, so I had to take this off, the whole linkage system, just to give it a couple of welds to strengthen it up before we move on to the next process. Okay, so that should be more than enough weld for the meantime. Just in case we need to modify it again. Okay, so we have the sliding bar with the sliding mechanism. The little 16mm bar welded on to the other sliding bar using this little 16mm bar to the side. So these two bars is parallel to each other and they're 50mm apart. So now I can place the tensioner, well, the cylinder part and the eye, the bushing, onto the bar that I have created here. So the next step now would be to find out where or what angle I want to have this little gearbox, where I want it tilted. So I want it sort of at an angle towards the motor. So I don't want it sticking over here because it's going to be in the way of the workpiece, just say on the chuck. So I want it as far to the left as possible. The motor itself, so we don't want the motor sticking over this way. We also need to make sure that this gearbox and the motor doesn't collide with the motor for the flange plate for the lathe itself, for the spindle. So we want a wee gap here of approximately about 5mm or so. So what I'm going to do here now is I'm going to put a wee mark at the back of it, just to sort of figure out the angle I want it. We'll take it to the bench, we'll tack it, and then we'll put it back on the lathe, and we'll figure out where we want this top mount point to be on the motor flange itself, motor flange plate. So that angle there looks good from here, so I'll put a wee mark in the back of it here now. There we go. So we'll take it to the bench here now and we'll weld it at that position. Then we will create the spacer plate if needed be, and the bolt or shaft here that will sort of act as another linkage point, just like a 60mm bushing. So we'll take this to the bench now and we'll weld this sort of in that angle, so you can see it's not sitting parallel to that face. This bushing will be sitting at a sort of like a 45-degree angle against this edge here, the motor. So we'll take it to the bench now and we'll weld it up and we'll put it back on the lathe and see how it all goes. Okay, so I have this lined up now, the little cylinder to the 3mm flange that I have created. So the gearbox flange. So what I'm going to do here now is going to put a couple of tacks on it. Then we're going to attach it back on the gearbox, and then we will slide it onto the little sliding reel, and then we will start making the linkage for the top of the motor to finish this little piece off. So you can see there I wasn't using no rod, so that's basically just so I could hold it down tight with my hand to make sure it's square. So that's it, tacked together, and now we're going to put it on the lathe now. So there you can see the little hole now that the rod, the linear screw, can pass up and down through. So looking good. Okay, so just screwing this back on here now to the gearbox. So it doesn't really need to be that tight. So that's the right angle anyway. Looking good. So we'll slide her on here now and see what it looks like. Okay, so looks good. So what I need to do now is create a linkage here for the top. So this linkage will be basically welded to the face of this plate. There will be a spacer and then some sort of bolt, like a M10 bolt to sort of lock so this linkage can't fall off again. So a nut, a bolt, spacer and a flat bar, and it's looking quite well from this angle anyway. So we'll do that now. We'll start cutting the plate for here first. So I'll start cutting that now. Okay, so we're now moving on to the top linkage. Before I start, I should probably point out here that this distance in between this gearbox and this motor, we want it to be about 5mm. We don't want it no less, just in case the two of them collide with each other. But the bushing is quite tight to the shaft, so this shouldn't happen once we have this top linkage made. So I measured it already there, see images at the end. It is 30mm between this flange on the linear screw to the motor mount plate. So we need now to make a linkage at this point. The further out, the further away from the centre of this motor, the better. So we're going to actually have it at approximately 25mm away from this hole, just to keep it a wee step out, so it's a better angle and it allows the better tightening and there's no binding and stuff, so it's just much better to have a bigger angle rather than having a smaller angle. So there's more force, if that makes sense. So if I have this too close to the centre of here, so there's the hinging point for the motor. If I have that tensioner too close to this point, too close to here, it's going to create problems. So the further we have this away, the better. For example, if this tensioner was at this point to this point, there would be no problems tightening that motor, but you need a bigger stroke. So this is why I've basically moved it down here, so the shorter it requires a shorter stroke, tightening and slackening the motor. I'll draw a wee diagram at the, after this just to demonstrate that, maybe. So what we're going to do now is we're going to make a linkage from here to here, approximately about, when you see this should be screwed out at this point, at the high gear. So we're going to make a linkage from here to here, and we have it all on the bench here ready to go. So we have this plate, so this is going to be the bit that steps out the linear screw away from the motor. So it's going to be about 25mm out with this plate. This plate will be welded to the motor point here. We then will have a spacer, and then we will have a bolt. So this bolt is what's going to be fixed into this linear screw. So you can see here, it's not, well, it is fully threaded, but there's a wee bit on the inside there that's approximately about 10mm. So that's good, because that holds 10mm. So this bolt, the depth of it from this face to this face is 9mm. This plate is 6mm, so that's 15mm. I need to make a spacer now of 15mm to make up for the 30. So I'm going to start cutting everything now, and hopefully it all goes well. So just a wee sample rectangle plate. This bolt will be welded to this bar, and the bar will be welded to this. So we're going to start cutting this plate now in this bar, and hopefully it all goes well. Okay, so we're going to weld this wee M10 bolt to the 16mm bar, or to the spacer, and then we will take it to the lathe and add this little plate to the motor plate first, and then we'll tack everything in position, and hopefully it all works. Okay, so that's it finished. We're going to take it to the lathe. Well, obviously it's not welded yet, it's just tacked. So we're going to take it and put it on the little linear screw now, the flange, and then we will weld it to this little plate that offsets the linear screw away from the motor. So yeah, we'll do that now. Okay, so now you're ready to do the final touches here. So I have the cap bolt welded to the spacer. The spacer is approximately 15mm, the cap bolt's 9mm, and this plate's 6mm. So that should add up to approximately 30mm. What did I see? Yeah, that's right. So the next step now is attaching this little linkage point. So what I'm going to do is I'm going to use this plate to protect the aluminium motor so the vice grips don't mark it too much. And then this plate is going to be attached somewhere around here. So that looks good. So now if we move this little spacer into position, so what do we see? There's a car passing here. I have to make sure that the stroke's right, so that I have the ability to slacken the belt, or I'm capable of slackening the belt, and also tightening the belt in the 3 different stages. So the stroke's out full, right? So if a stroke's out full, I want to sort of adjust this plate at the minute up a little bit until, yeah, so that's not bad there now. Maybe a wee bit more. Let me see here if I can adjust this up. Actually, I'm not going to touch it, I'm just going to screw this in one turn. Oh yeah, okay. So we're getting there. Okay, so that looks good at that point. So there we have it. Hopefully that's the final positioning of everything. Now when I slide the motor to the left, the tensioner should also go to the left. A bit of grease on both of the 60mm bars. So what I'm going to do here now is I'm going to put a couple of tacks on this. We're going to start with this little 6mm plate to the motor flange plate. So let me see if I get the welding torch around here, so I'm not interfering with the camera. So I'm just going to put a couple of wee tacks on it. Actually, I'm only going to put one on it for the meantime, just so I can move it if need be. So the next thing now is actually tacking this to here. So what do we see? Looks good, so I'm just going to go ahead and tack it here. Okay, so the reason I hold the torch after I finish welding is just so the argon sort of cleans the weld pull, or the weld that it created. So I can tack a spacer at the rear end of it too, just so it doesn't break off. Okay, so looking good. So what I'm going to do now is I'm going to get a wee power pack, and I might put one wee tack at the bottom of this lever, just in case it breaks off. I think it might be okay anyway, so we'll just give it a wee tack. I'm going to need the vice grips again. Just so we don't mark the back of the motor. So once we have this working, we're going to use a filler rod to weld it up completely. But for the meantime, that's it. So we're going to do a wee test here now. I might take a lathe outside into the daylight. Okay, so we have this little tensioner complete. So I'm going to put it together here on the lowest gear first, to demonstrate it working. So that's it, built up there now. So you can see that I can slide the tensioner with the motor. A wee bit sticky, it needs a wee bit of grease. So what do we see here now? So what I'm going to do is I'm going to apply 12 volts using this little power supply. So this power supply is rated 5 amp output, so it's more than big enough, capable of driving this little motor. I think the motor pulls about 2 amps, depending on the load, the force. So what I'm going to do here now is I'm going to tighten the belt. So that's me tightening it now with the actuator. You can see me applying the power there. But there's a problem. A problem that I sort of knew was going to arise. So if I slacken the belt now again to demo this. So when I tighten the belt, let me see if I take it off and show. The mechanism's working brilliant, but when I tighten the belt, this plate is tending to bend at this point because it's only 3mm thick. So due to the extreme force that this here's, the pulling force that this here is applying, this plate is curling. So this plate is curling in this way, sort of pulling the motor in, and it's bending at this point. So what I can do is I can try and reinforce it. I don't have much room. Sorry with that car passes. So I don't have much room because the belt passes here where these two black marks are in the different gears. So what I'm thinking about doing is actually changing this plate to 10mm. Also, there's a wee bit of play here, look. So if I grab this motor and do this, do you see that side play? I'm going to try and reduce that too. So I can reduce that by stepping these bushings out over this way a wee bit. So I have 25mm to work with until it hits this bracket in the last gear of the pulley. So what I'm going to do now, right, is I'm going to take this off, dismantle it, and make a new plate or reinforce it. I'm not sure yet, but I'm going to start it in a wee minute. But I'm going to demonstrate it first in the highest gear. So what I need to do is I need to put the belt on first. So in the lowest gear we have, so that's the position of the lowest gear. So that's it. Not on. Let me see if I get the whole thing in the view here. A wee bit tricky. Okay, so hopefully you can see that now. So if I want to tighten this belt, I basically apply power. So you can see there that the motor sort of shot into alignment. The belt jumped over as the belt was tightened. So look how tight that is now. It's good apart from the plate bending. So if the plate's bending, that means the pulley is going out of alignment with this pulley. So I'll slacken it off now. I'll do a wee demo of it in the middle gear. So this is now going up the gears, mechanical gears. So if I slide this across to the middle, again, tighten the belt. Oh, that's the power supply. So there's a demo of it twisting the plate. So I'll take the camera off here 2 seconds before I move into the highest gear, just to show the plate twisted. So if you look down in that there now, look, you can see that the motor is twisted this way. You can actually see a gap up here and here in the middle, this face. And this is bolted at 2 points. So there's a lot of strain there at the minute on that bottom plate. So yeah, wee bit more work, but we'll get there. So I'm going to slacken this off now. Oh, is that the wrong way or right way? That's the right way. So we're going to put her into a higher gear just to test the mechanism out. Make sure it's working. And the other gear, make sure the rod's not going to shoot out. So, or it's not going to shoot out, but it could have the stainless cylinder thing here at the back. But as you know, I've already made that to suit. So there we go. There's the belt tightened now in the highest gear. So hopefully you can see that nice and clear. That's nice and tight. So I'm not going to demonstrate the motor going until I fix this problem. When this problem's resurrected and fixed, I'm going to do a demonstration again of the tensioner and this plate, hopefully not bending. So again, I'll just show what the problem is. So at this point down here where I was bushing and the 3mm plate is, sort of knew it was going to arise and it happened, but I didn't think it would be as bad as it is. It just shows you how much force this wee actuator, the pulling force of it. So this is all good, the mechanism. So I'm going to move on now and start making a plate for this or modifying it. As you can see, I can't even get my finger down here, so there's about 10mm gap there, 9mm, and there's just maybe a wee bit impossible to try and reinforce to that bushing, to this plate. So I think I'm going to make a new plate, and I think I'm going to make it out of either 10mm or 12mm. If I make it out of 12mm, I can just step the pulley out a wee bit from the motor. So we're going to start that now. I hope everyone enjoys. More work, but quite interesting. Okay, here we go. Okay, so I have removed this old motor flange plate that was bending at this point. So the 16mm bushings are also removed. The next time I place the bushings on the plate, one of them will be 25mm to the right. So just to create more stability, so the plate's not shaking as much. The plate will also not bend the next time because the plate I'm using at the minute is exactly 12mm 316 stainless. So what I've done here is I've used the old motor plate as a template. Okay, so one other thing I'm going to point out here before I start cutting this is I have to go get a lens of my friend's plasma to cut this because I actually don't have one. So sorry, there's a bit of hair in my face there. Right, so this little piece, this little linkage point for the tensioner that I made earlier used to be welded onto this plate at this point. So what I'm going to do this time is I'm just going to continue this tab on out and sort of like this sort of triangle shape here. I'm not going to go out that point, I'm just going to cut it off, or maybe I might round this. Round it rather than having a big square lug here. This little spacer then will be reduced down the size to compensate for this plate. So if this is 6mm and this is 12mm, I'll obviously be taking 6mm out of the spacer. That then will be welded to this point. That will be a hole for the motor. Rather than creating a pile of holes for vents this time, I'm just going to do one big circle because the plate's much more going to be much more rigid at this point over this distance here and here. This will be out to about 17mm to allow the 16mm shaft to clear accordingly. So yeah, so 1mm clearance right around it. The bushings then will be welded to this plate. As I say, they will be further apart this time to sort of steady the motor plate. So that's it, we're going to start cutting this now, and then we're going to have to cut, well, once it's cut with the plasma, have to tidy it up with a Dremel, carbide burr, and the grinder. So Asimo, smile, there's Asimo in the background, usual. So that's us, we're going to start this now. Okay, so we're boring out the holes here now for the motor again. So we're using the old motor plate as a template, as a guide for the drill bit. So again, it's 12mm thick 316 stainless, so it's quite difficult to bore. We didn't have a pillar though. Okay, so we're going to move on now to cutting this surround right around the edge here. This tab, it won't be, if you can see it there, this tab will be also won't be included in the new plate because obviously that's not the mounting point for the ram. This is now the mounting point, or sorry, for the tensioner. So let's go. We'll get this cut out and we'll get it back on the lathe. We're going to start cutting around the outside here now, and then we'll move on to the inner part of the plate. So we'll use this ring to sort of as a guide to go around it. So we're going to start cutting this hole now for the pivoting point and the outside. Have to make sure to keep this tab here and cut this tab off. So we'll just flip this plate around 90 degrees to remove this tab after we cut the most of it first. Okay, so now we have to flip the template, cut off this tab that isn't used anymore. All done. Okay, so now that we have the edges of this heavy 12mm plate nice and squared up, the next stage now is to give it a wee flatten of the dual action sander and to remove any wee scores that the grinder left. I will also use a little bit of water to aid this process. So here we go. Okay, so you can already see there it sort of spartans it up a wee bit. I'm going to also do the edges as well as the two faces. So I might need to change this. So the grit I'm using here is 80 grit sandpaper. Let's see if I can get up a wee night here. There we go. So I'll put a new one on here. Oh sorry, 40 grit I'm actually using. Okay, so I think that's good enough. You're not going to see it when it's on the lathe. There'll be a guard over it, possibly in the end up. So what I'm going to do here now is we're going to start welding on these bushings again that were on the old plate. So what is see if I bring the old plate into view here. So this is the old plate, this is a new one. So what I'm going to do now is I'm going to weld the bushings on. The compressor squealing in the background there. So we'll do that now and hopefully it all goes well. Okay, so we'll start these holes, tapping these holes off with a drill here. A bit of CT90 cutting fluid. So we'll do them all. Okay, so we're tapping these 4 holes now out to M8. The thread pitch is 1.25. So the drill size I drilled the holes is about 6.8. So much more meat or thickness this time from 3mm to 12mm. So much more for the bolt to grab onto and threads. As you can see, I don't have a tap wrench, so just using a plumber's wrench at the minute, adjustable spanner. So that's one done. So I start them off with a drill just for handiness. Well, 3 more. Then we'll move on to putting these bushings back on it. So these is the mounting points for the motor itself. This time I'm going to use hexagon heads rather than the Allen keys because they get more tightening. Now the Allen keys could chow. So there we go. Okay, so we're starting to weld these bushings on here now. So the hole that I cut out with the plasma, well, and then I bored it out to 18mm. So what I'm doing here now is I'm lining the bushing up to the 18mm hole. So the bushing center is concentric with this hole itself on the plate. So I'm going to tack one bushing on, and then we're going to take this to the lathe. So the first time I done this, I placed a bushing on both sides of the plate. This time I'm going to step the bushing out and sort of make use of the extra shaft that we have that I have made up, the sliding shaft. So I think I'm going to add in about 20mm or so, depending on how far this plate needs to go over for the last V in the pulley. So I'm going to tack this one on, and then we're going to make a little spacer to put onto the plate and then put the bushing onto the spacer. So this will create more stability when this plate's side action like this. So the more stability means the less play here at this point, means more accuracy of the belt on the V-pulleys. So this plate always sits perpendicular to the shaft when it's sliding. So we'll do that now, we'll tack this. So we're ready to go and all here. Okay, so that's one tack on. One tack done even. So I'll take this welding helmet off. So I'm just going to double check it's still sitting nice and concentric, which it is. So I'll get a tack on the back here now too when I'm at it. Get the air flap on again. Just a wee bit of rod I'm using here for the meantime, so just in case I need to cut it off again. Okay, so just holding the gas on to shield the weld so it's cool. Keep a nice clean weld. So that's it. You can see the bushing there now. It's nice and concentric with the 12mm plate, or sorry, the hole, the 18mm hole. So next step now is taking this to the lathe. So as I say, rather than weld this onto this side of the plate, I'm going to move it out for more stability. So we'll do that now. Okay, so now moving on to the little bushing on the right. So, where to start with this one again? So, this bushing, right, what I done on the older motor mount plate is I kept the bushing tight to the plate like this. So, these bushings being tight together is going to not remove as much play as having it further out. So the further out we keep these bushings, the more stable this motor mount plate will become, and the motor itself. So, when I give a wee demonstration looking down on it here, so let me see if I bring it over. So at the lowest gear, the biggest part of the pulley, or the third tier of the pulley, the third stage, that's as far as we need that motor to go to the right. So do you see this little space in here with my finger between it? It's approximately, see if I get the tape measure here, I think it's about 17mm. So what do we see here now? So if I put the tape measure here, so it's reading 18 there. But I measured 17mm a minute ago. So what I'm going to do is I'm going to make a 17mm spacer for in between this. And the reason that, as I say, I'm keeping it further apart is because you can see here at the minute with this, the one 16mm spacer, what do you see how much the motor moves? See that? So that's a 16mm bar and a 16mm spacer. It's better having a wee bit of play there. You don't want it too tight because stainless will bind. But that's why I've got a wee bit of grease in the shaft there at the minute. But you also want it to be stable, like so on the belt. When I put the belt back on again, so the belt's running through or straight. But we don't want it to flap about like this. So what I'm going to do here now is we're going to move on to making this little spacer. We will tack this bushing to the spacer and then the spacer to the motor mount plate. And then we'll see how stable it is then. And hopefully it turns out well. So here's the little spacer that I'm making. I wish I had something like 3mm. So this is only 1.5mm dairy pipe, 25mm diameter. So I'm going to now cut 17mm off this. I'm going to weld it onto a spacer bushing. I'm going to weld the spacer to the bushing, and then I'm going to weld the spacer to the motor mount plate. So start cutting this now. Okay, so I'll square these two edges up now. What I just measured here before, make sure it's right. Okay, so it's measuring 17mm. So as I say, it's 1.5mm thick. If it was any longer, I would have needed something with a heavier wall, but only, see, because it's just like 17mm, it should be okay for doing what it's doing. So the only way to know is we're going to weld it together and try it out and do a wee test on it. So what we'll do now is we'll clean these faces. Perfect, so we'll start welding this together now. Okay, so we are ready now to weld this spacer to this bushing. So it's not really important that the two of them are perfectly concentric to each other, but it is important to have this bushing concentric with this one in order to keep the plate perpendicular to the shaft, this face. So what I'm going to do here now is we're going to tack this spacer to the bushing, and then we're going to tack the spacer to the motor plate. We're going to use a 60mm shaft, and we will tighten we'll use two bolts, two 6mm M6 bolts. We're going to use the little threads that are available in the little bushings to square the shaft up. So I'll gently tighten the shaft. So I'm not going to get into detail, I'm going to weld this up first. So we're going to line the two of these little pieces up as close as possible. So that looks okay here. Okay, so that's one tack. It looks near enough, I think. I'm not going to get it any better, so we'll give it a wee clamp and tack the other end. Put this plate in to keep things square. I'll keep the pressure on the one side that I'm going to tack. So again, another tack. 180 degrees around. So just fusing at this point. Fusing the metal together, no rod. So this is it, sort of two of them sort of concentrically to so I think it's as good as I'm going to get. Well, you know something I could do better. So what I'm going to do is I'm going to stop the camera and I'm going to move it over a little bit. Yeah, I'll take pictures and then I'll start the camera rolling again. Well, do you know something? Do you see now that I've welded this side and this side, it's sort of this little round piece of stainless pipe is sort of not round anymore. So what I'm going to need to do, I might just go ahead and leave it alone actually. Squeeze it here at this point. Well, vice grips to sort of square it up again. So, as I say, I probably should have used 3mm gauge or something here, but I didn't have anything. So it looks alright like that. So what I'm going to do is I'll just put another tack on it here. Now that it's straightened up. So if I be too fussy, I'll never get nothing done, so it's okay. Looks good now actually. It just went out of shape and the heat was starting to cool down there. So what we're going to do now is we're going to put this on here. We're going to keep the two threaded holes facing the same direction, which is out the bottom. I'm going to put a shaft up through the middle of it, just to keep things nice and square. Tighten the Allen key. And now put another one on here in this position. So the square, we get this, the square, the motor plate mount will sit on the sliding bar. Okay, so that's it. We'll tack this up now and see what it looks like when it's put back on the sliding bar. So we're going to use feather rod this time. Remembering to place the earth back on. Okay, so that's one tack. What I'm going to do here now is give it a little squeeze in the position it sits. Okay, so that's not big enough. So I'm going to have to use the vice grips. Okay. So we're going to tack the opposite end this time. Okay, so we have a good strong tack on it. So what we're going to do now is we're going to take it over to the lathe and try it out before I put any more tacks on it or any more welds. So hopefully it's nice and square. It looks good now, looking at the shaft. If you look at it, this bar looks perpendicular to this face, which is important. So we'll slacken these Allen keys, these bolts. I'm going to wait till it cools down first because I don't want any binding going on. There's a whole handle then. So we'll take these bolts off and we'll take it to the lathe. Okay, so we're going to remove these little screws now, the bolts. Oh, look at that. So it slides nice and freely the way we wanted it to slide. So these can be removed, they're not required, as you know. This is going to be an adjustable pivoting point. So I'll take this to the lathe here now and try it on. See if I get the camera sitting here somewhere. So as you can see, the lathe sitting beside us. Still. Hopefully you can see nice and clear there. And all I can see is grease on my camera. Greasy hands. So here we go now, first try. Oh, that's the wrong way. So let's see if you can see this. I think you can. So there we go. Oh, look at that. So that is incredible. There is minimal movement. Look at that. About a mil or less movement. So what I can do now is I can finish off welding this piece again, this bracket support. And then we will carry on with everything else. So I'll do that now. And then we'll do a wee test. One final thing. I have to tack this little linkage on again for the lever, for the adjustable mechanism that I have made last week until I ran into problems. But this now will slide on here. Oh, it's upside down. So let me see if I get it right. Okay, so that'll slide on here. We'll have this welded on this point. So here we go. Okay, so sorry there, I had to cut off. Somebody walking up the road looking to speak to me. So what do we see this now? So the final step now before I move back on to the pre-tensioner, this part here, we're going to finish off welding now that this is slid on. So this can be all welded in the future. So I probably should weld it now before I put it on the shaft, just in case it swells or anything moves, but I think it'll be okay. I'll just give it wee tacks here and there. So what I'm going to do now is I'm going to square this bar up to this one at the bottom, basically by clamping this to here, and then we'll start welding it. Everything else is finished. So you can see there how sturdy this is now. There's like no movement at all, which is quite impressive. So very good. I think this wee little spacer done the trick. So let me see if I get this back up to its original position. Using this little plate, so it's important here that I don't put the vice grips on this shaft, because I end up marking it and then it will start binding. There we go. So that's it back into position. So what I'll do here now is I'll tack it. Let me see. Let me get this in position too. So the welder's currently set at about 80 amps for doing this. So that's it tacked there now. Back into its original position. So there we have it. So that's some step up from this flimsy little plate to this one. Really well engineered now, if I must say. So what I'm going to do now is I'm going to weld the back of this, weld the bottom of it, and then I will move on to the pre-tensioner again. Just a couple of tacks for the meantime. Okay, so just a little final video clip of this little mechanism, the slider. So look, if I put my baby finger here and I use this heavy plate, look how easy it moves without sticking. So it's really good. No play whatsoever now that it's welded. So if I try and get side play in this, look, there's minimal. It's not even moving a half a mil. So that's brilliant. So it's quite strong compared to the first iteration. So what I'm going to do now is going to bolt the motor back on and see where we're going to attach this little linkage for the little adjusting mechanism that I made. So a lot of detail in this video overall, but you could also probably make out that this, when I was cutting this out on the plasma, this plate, I had a tab on it that was going to do this linkage point, but I actually put the tab to the wrong end of the plate down here, and I wanted it up here, so I made a wee mistake. So it's not hard to fix. I'm just going to weld on something like this again. So we're going to mount the motor here now and start working on the tensioner to finish it off. Hopefully this time it'll be perfect when I go to well, use it, switch it on back and forward, and I think it'll be brilliant this time. Okay, so we're going to start to mount this motor now. So do you see the cable for the motor? I'm going to keep it to the bottom. So basically when the motor is in position, the cable is to the underside of it. So using the M8 bolts that I have pre-cut, they are about 20mm long. So the reason I have pre-cut them is because I don't want them passing this face at the side, because the belt's obviously just skimming the plate when it's in its position. So we'll put these on now and then we'll start the pre-tensioner again. Okay, so tighten them all up now. Okay, so now we'll tighten them with the ratchets just to make sure they're tight. Okay, so that's it, mounted. So now the belt is on also. Let me see if I get the camera in position here now. Okay, so we can see here the motor is still easy to slide, or the motor plate with the motor attached. The lace rocking back and forward right enough, it's only hanging together. So what I'm going to do now is I'm going to start the tensioner again, picking up where I left off about 2 weeks ago. So yeah, let's go, keep her rocking. Okay, so we have the motor set up in lowest gear, ready to go. So the tensioner now sliding on to the existing sliding reel that I made, well, 2 weeks ago, until I ran into problems with this motor plate. So we're going to start and attach this little linkage back onto the motor plate. So as I said there in one of them video clips, I used to have a tab on this plate when I was cutting it with the plasma cutter, but I put the tab to the bottom instead of the top, so I made a wee blip. So I'm just going to use the one that I had made previously. It's looking good. When I place it on this little eye, this little linkage, it's sort of sitting where we need it to sit. Still, what do you see? Just minor wee tweaks here. So I'm going to clamp this now with the vice grips. I'm going to put a couple of tacks on it, and then I'm going to test it again. We're going to put the nut on here first, and then we're going to clamp it. What do we see here? So I have the nylock nut cut with a tap, just so you can see me screwing it on there nice and easy. What I'm going to do is I'm going to take this welding mask off for starters, and I'm going to line this up to where I want it. Okay, so I'm just going to put one tack on it for the meantime and do a wee test. So you probably can see there that I bought the lathe outside just to show, try and give a better demonstration. So we're going to get the wee power supply here now and then give it a wee test run. Okay, so that was kind of silly of me. I should have tacked the underside too. So I ended up nearly having the tab broke off again. So just going to tack the bottom of it here too in a couple of places. Okay, so that's it. Do a wee test run here now. Okay, so I have decided to give this a good bit of welding because the force, the pulling force of this little tensioner is quite excessive. So what we're going to do is we're going to weld down the side. I've got around the little spacer and the bolt welded. So what I'm going to do now is going to put a good wee bead on where this little plate, offset plate, goes on to the motor plate. So here we go. Hopefully I can get in here if I tumble and everything. It might be better just taking this off to the bench and finishing it off. But for now, I'll do a little demonstration of it working. So what we're going to do here now, before it's only a wee quick insight until maybe I do a proper video at the end up. Let me see if I get this on now. So this needs extended out. Okay, so a little final video clip here of this little power supply, this little control unit that was taken out of what do we see? A body sculpture vibrating machine. So that's basically what this motor was off. So if you want to see the stripping process or what the machine looks like, look for part 1 of this little project on my YouTube channel. I think it was part 1 or the introduction. It might have been an introduction video actually, that the stripping of the machine came in. So what I'm going to do here now is I'm going to connect this power supply up to the motor that I've attached to the lathe. So basically we have these 2 wires here, positive and negative. We'll connect them to the power supply. We will just sort of give a wee quick and final video clip of this motor working. The spindle will not turn at this stage because I have it all dismantled. You can see the shaft here sitting out approximately about 60 or 70 mil, 60 mil approximately. So that will come in the future when the chuck and all is back on and everything like that. So what I'm going to do here now is I'm going to connect up the power supply. So I'm going to put the camera on the stand again for the final time. So I think it's okay there. So what I'm going to do now, we have this connected to the mains already. So I'll need to watch my pause. So basically I'll plug the motor. Let's see if you can see what I'm doing there. So what I'm going to do is I'm going to plug a motor into the power supply. Like so. Then we've got this control unit. So as I say, part 4, I'm going to start making a nice panel for this out of stainless steel. But for the meantime, I'm just going to demo here this motor working. The spindle on the lathe will not, this won't turn because I have a bolt out of this gear assembly to this 3-stage pulley. But I'm just going to demo it, the belt and the motor working anyway. So here we go. So power on. Time I want the machine to run for. So I'm going to say 300 seconds, which is 10 minutes, is it? Yeah, and then I'm going to go through the different speed settings. So I have 1 electronic speed, 2 electronic speed, 3 electronic speed, 4, 5, 6, 7, 8, 9. Okay, so if I go now. Okay, so we're going the wrong way. So, no. What do you see? The lathe cutting down. No, that's the right way. So if we were going the wrong way, all I would need to do here is reverse the polarity where I put the 2 connections on the power supply board there. On this board. Forget about the tensioner. So if I want to speed the lathe up, you can see there that at the minute that the motor's giving a wee jump. I should probably point out this assembly gear is completely stripped, and I'm just doing this to sort of give a wee quick demonstration of it. The shaft are nothing is centre and the lathe and this bushing here at the side. So I'm just going to turn it off quick after I do this. So I'm going to go up through the 9 speeds here now. 2, 3, 4, 5, 6, 7, 8, 9. So there we have her going flat out. Going to stop her. Right, I'm stopping her there quick because I should also point out that this lathe has all the bolts and the nuts taken out of it because I'm still in the process of doing it up. Okay everyone, so to wrap this video up, a few discussions on future projects and on the finishing the lathe. So okay, so in 4 weeks time I will upload another video on designing and manufacturing a nice stainless steel surround for this control panel that's taken out of the the exercise machine. I also have to cover yet stainless steel yards, compartment for the circuit board that you've seen there out of the exercise machine. So I need to contain that yet. I need to build a stand for it, which will obviously be out of stainless steel. I need to spray, sandblast, spray. First things first, need to remove all the grease off it. I have a lot of work to do. Not only that, I have other projects running alongside this one. So, yeah, so I have a lot to do. I hope you enjoyed this little project, tensioner. A lot of detail on it, a lot of work, but a wee bit of modifying, a wee bit of altering parts there. So didn't mean to do that, but I had to. Just experimenting. So sorry about that mess ups. It's working now. So thank you for watching. Do come back for more interesting projects in the future. As I say, there will be ones running alongside this. This one will come in 4 weeks, but also there's another one coming alongside it. Quite interesting. So thank you for watching and goodbye. Okay, so it's been a long journey, a long video. Sorry about that, but additional manufacture here now. So I have attached loads of images throughout the manufacturing stages. So here we have the little plate, a clone of the existing plate on the gearbox. It was made out of stainless, then it was screwed to the little gearbox, and then the cylinder was attached to it to act sort of like a ram, an electric ram. So here you can see the screw protrude down through the gearbox. Here we have the little 6mm plate that was filed, as you've seen in the video clips, into a nice neat circle, so it could be placed in the end of the cylinder. So here we have it placed in the end of a cylinder, ready for welding. At this stage we are making a little bushing and shaving a part off it with the grinder, so it's set flat, the two surfaces met nice and neat before welding. So here we are ready to weld. Few tacks required before the initial testing procedure. So here you can see the inside of the cylinder, where the little screw, the linear screw, passes up into. Again, as you've seen in the video clips, these are the little sliding mounts that were required for both the spindle motor and the tensioner. So two independent runners or sliding bars, as can be seen here. So the lower ones for the tensioner and the top ones for the sliding mount. Here we are taking the cylinder, the little enclosure, the mounting point for the little tensioner to the plate that I have cut out here. A lot of work required in this little part of the project. Basically because it's a sliding mount and a tensioner that can be tensioned between 3 different stages, if that makes sense, rather than just one point. So this made it quite tricky and difficult. So here we're measuring for the spacer between the old motor plate. This was then altered. The spacer was made shorter. Okay, so this is the linkage for the top that was welded to the motor plate. The first motor plate and the second. Here we have the spacer and the linkage point, which is a bolt. Okay, so this is why the video was twice as long as it was meant to be. The motor plate had to be modified, made much thicker to make it more stable, take out the flex. So the 3mm plate was flexing too much. So here we are cutting the 12mm plate out using a plasma cutter. Yeah, so the existing tabs was cut off, that wasn't required at the top there. And then at this stage we are ready to cut the center here. So after this was cut, the edges needed to be all cleaned up using a carbide burr, grinder, files, anything really. to take away the bad burr, the bad edge there. So at this stage the 12mm plate was finished, and here we are tapping the holes. We're starting to tap the holes using the drill, and at this point the plate is finished, ready for the 2 stainless bushings, the linkage point. So this turned out quite well. A wee bit of experimental, wee bit of an issue there with that plate, as could be seen in the video clips, but came together well in the end. So here we are tacking the bushings back on, so making the bushing concentric with the hole that I have cut, which is 1mm bigger. So the bar doesn't, the plate doesn't interfere with the shaft or the bar going through it. So it doesn't cause any binding. So at this point we are ready for the other bushing at the other side. However, this time I stepped the bushing out at 25mm, I think it was, or 20mm. Looks to be 20mm there from that image. So yeah, it all turned out well in the end. The plate was less play in it. Very good. Actually a lot less than half a mil movement. Maybe I'd say a tenth of a mil movement, side to side play. So this meant that the belt was running nice and true to the 3-stage pulley. So the V-belt on the motor and the V-belts on the lathe, the 3-stage pulley, were true and parallel to each other. So here the bracket's finished. So that's it everyone. I'm sorry it's a long process, a long video, but it all came together in the end. Thank you for watching. Do come back again for more interesting projects in the future. Hopefully they won't be as long as this one. Thank you, goodbye. Oh, I nearly forgot. Please don't forget to subscribe to my channel. Goodbye.